Inverse variation. All right, so we've talked about direct variation equations before. So you should remember that a direct variation has an equation in the form of y equals kx. The constant k is called the constant of variation. So we've seen this type of equation here before. We can write it as y equals kx, or we can also think about it as y divided by x is equal to k. So that is with our constant. So now we're going to talk about an inverse variation. And that's an equation in the form of y equals k over x or xy equals k. So we've now changed things where I'm going to multiply the two together to equal my constant, whereas before we could divide the two to get our constant. So let's take a look at some patterns here and decide whether they are inverse variations or direct variations. So determine whether each table or equation represents an inverse or direct variation and explain. So we start with a table, and we're going to take a look and see what the pattern is for that table, deciding which kind of variation it is. So at first I'm going to start with my inverse variation. So I multiply the two together to see if I get a constant of variation. So 3 times 6 is 18, 5 times 10 is 50. So since I don't have a constant, it's not an inverse variation. Let's see if that works the other way though. If I do 6 divided by 3, it's always y divided by x. 6 divided by 3, that gives me 2. And 10 divided by 5, that gives me 2. If I keep going, I do see the same pattern. 16 divided by 8 is 2, 24 divided by 12 is 2. So the equation here would be y equals 2x, since that constant is 2. So this is a direct variation equation, because that looks like our direct variation format. Our next one, y equals 6x, well that's pretty straightforward. That is in a direct variation form. So it's direct variation because it looks like our y equals kx. And our last one, x times y equals 15. This is inverse variation because, again, it's that same pattern, that x times y equals k. And when we think about that inverse, we think about as one of the numbers going to increase as the other one has to decrease in order to keep that same constant of variation. All right, let's see how we can work with our inverse variations. So the product rule for inverse variation says that x1 times y1 is equal to x2 times y2. So I can take my input and my output, my range and my domain value, and since they're equal to the same constant, they should be equal to each other. That product should be equal to each other. So assume that y varies inversely as x, write an inverse variation equation that relates x and y, then solve. If y equals x when x equals 5, find y when x equals 2. And this should look very similar to when we work with direct variation, very similar what they're asking from us. We're going to write an equation, and then we're going to find that missing value. Except that for us, the equation is going to be x times y equals whatever we come up with as the constant, as opposed to x times our constant is equal to y. So x times y equals the constant. So I'm going to take the input and output that I know go together, my x1 and y1, if we think about them that way. 5 times 10 equals k. So k is equal to 50, so my equation is xy equals 50. So now I'm going to use that equation to figure out my missing value if x is 2. So x times y equals 50, 2y equals 50 divided by 2, I get y equals 25. So two pieces for this. What's the equation and what's the missing value? Second question, if y equals negative 7 and 5 tenths when y equals 25, find y when x equals 5. So x times y equals k, 25 times negative 7.5 must be equal to k, which means k is equal to negative 187.5. So here's my equation, xy equals negative 187.5. Now I'm going to use that equation to find my missing value. I'm going to plug 5 in for x, and then solve for y, and I get y equals negative 37.5. So there's my second part of that question. And the last question we'll work with for now. The Girardi family can travel to Oshkosh, Wisconsin from Chicago, Illinois in 4 hours if they drive an average of 45 miles per hour. How long would it take them if they increase their average speed to 50 miles per hour? So we can work here with our distance, rate, time formula. Distance equals rate times time. I'm going to plug in my rate and my time here, 45 miles an hour for 4 hours. And that gives me a distance, or a constant here, of 180 miles. So they're going from one place to the other. It's 180 miles. That makes sense that that's our constant. They can change their time. They can change their speed. They're not going to be able to change the distance particularly. So we come up with an equation, 180 equals the rate times the time. So if they increase their speed to 50 miles an hour, I'm going to see what happens to their time. Now if they increase their speed, since it's an inverse variation, their time should decrease. So if I put 50 into here, I get that their time is 3.6. So they can make it in 3.6 hours if they increase their speed to 50 miles per hour.